as we know, 2610 has 3 different sub-modules, which are M3 that does the security core, M52 that runs our RTOS, which is the MCU domain, and we have an A55, 2-core A55, that's our MPU domain running Linux.
Can you show them here? So which one are you running on batteries now?
So the entire system is running on battery. Everything. So M52, that's your M class. And then you have your CPU, which is your A class on top. So what you're seeing right here is the battery drives the entire board. The board is, through the MIPI interface, is connected to a display panel. So right now you see a grayscaled panel. That's driven by RTOS, MCU, M52, System Manager, which runs right here.
That's a Cortex-M, so
Cortex-M52. Now I switch to A55, which A55 drives GPU. The GPU renders this whole color screen. Every 15 seconds, I'm going to rotate between MPU and MCU. You can see how fast we can rotate between the 2 subsystems. And this shows how much power it takes to drive the entire demo. And if you use your finger to touch this, you can see there's no temperature, almost no temperature at all. That shows minimum power it takes, unlike our previous generation where we have to apply a heatsink. This one can go without heatsink, which makes perfect for IoT
Are you in a low power mode?
Once we're in MCU, we're in a very, very power saving mode. On the MPU side, that's your high power domain because Linux demands more power. So this demo shows we can transit between the 2 subsystems without much of a display delays.
And is this a completely new architecture in terms of the low power mode?
Yes. So M52, using M52 as a system manager is a new architecture design we added with the 2600 family. And we will carry this same design in our future generations. This M52 really gives us more power to control the power, more ways to control the power because the system manager can rely on RTOS, which consumes less power compared to
How much power comes from 2 little AA batteries? It's not a lot, right?
Yeah, the 2 AA, that's your 3-volt normal, like I don't know exact power number, but these 2 batteries, if we continue to run this today while we're doing this, it lasts from this morning, it's about 6 hours running this. But your typical IoT...
Including the AI engines?
The AI engines, the same AI engine which I showed earlier. So it's the MPU that is Torque MPU running inside this system, 2600 family.
And here you have some partner boards already?
Yes, so we have various partners from Brain and Technician. They're taking our 2610 chip and come back with their own SOM design and their OEM ready designs. So these are the things that you can, this is from Grain.
All right. What is the software story you would like to highlight in terms of, it's such a nice open source philosophy you have in the company, right?
Yes, so previously we introduced we're going to the Yocto. So we really benefit from this. So it is amazing. Team has done an amazing job. This chip, everything you saw right here, exactly 1 month ago, September 15th, we just got the chipset back. So within a month, we're able to bring up the chip on our PEK development board. We're able to bring up the chip on our reference development kit, which is the Astra Machina boards. And we're able to get the SDK ready. If you check our GitHub, today we released Astra SL 2.0.1, which is specifically for our 2600 family. And everything you saw, today's demo, they're running. All these work we have accomplished in one month. I'm super proud of my team. Our team members can deliver all these, both from hardware team and software team.
How did you organize a team?
So we have a we're international company, so we have development centers around the globe. So we have a headquarters in San Jose. We have our BSP team, security team, and OS team, kernel team in Shanghai. We have our AI team, display team, and graphics team in Bangalore. We have our AI architect in Switzerland, Paris. So we're everywhere. We have our solution designers in Irvine. We have our application engineers everywhere around the world. So we're really consolidating all our engineering power together to make it live. And this is what we saw today.
Is it true that software engineers enjoy more working in open source?
I do think so. At least that's my personal preference, because we can quickly adapt a particular open source. For example, the Moonshine. It's a model that we can quickly quantize on our MPU hardware architecture and showcase its capability on our hardware. If everything is closed sourced, we won't be able to deal with that.
And then the NPU has this subsystem with a RISC-V.
Yes.
Is it fun to work on that area too?
Yes. So this generation of it, which is our new generation of NPU called Torque. Inside the Torque, we have a general purpose RISC-V core, which is partnership with Google. So Google R&D team is actually working together with Synaptics to design that part. So that general purpose of the core should be able to allow us to deal with the future models in case next generation of an AI model, who knows what, right? We have the convolution, now we have a transformer, and next generation may have other operators we don't support in our hardware today. But that general purpose RISC-V core should allow us to execute those unknown operators on the same MPU hardware. And that's the day we're looking forward to.
What is the feedback you're getting from customers, from partners, or people in the open source community? What are they saying what's happening right now? Because it sounds like you're pioneering a new kind of way of doing edge AI.
So we want to make this easier for AI community or edge device community. So not too many edge device communities, they have their open source components, but they're not able to showcasing edge AI running on their device. That's what we're hoping to bring to this era. We want to show the complete readiness of the SDK with the pre-bundled AI application completely open source, so they can quickly modify according to their needs and make that product available to the market. That's our goal.